In this lesson, we're going to look at section 3.7, multiplying polynomials. In this lesson, you will learn how to extend the strategies for multiplying binomials to multiplying polynomials. Multiplying two polynomials. So when we multiply a polynomial, we can multiply a monomial by a binomial, two binomials, or two trinomials. It doesn't matter what type we have, the multiplication process is the same. The distributive property can be used to perform any polynomial multiplication. Each term of one polynomial must be multiplied by each term of the other polynomial. The process for multiplying polynomials with more than two terms is similar to multiplying a binomial. Verify the polynomial product by substituting a number for each variable in both polynomial factors. So once you have your polynomials that you're going to multiply, you can verify your solution by using a number for your n or your x, whatever your variable is, to see if you get the correct answer. It's a good thing not to use 0. That will give you an inconclusive answer sometimes, so it's better off using a positive number if you're going to use this substitution method for a verification. If the value of the left-hand side equals the value of the right-hand side, the product is correct. So this is a very good point to remember if you want to check your answers and your solutions to see if you've done the process in a correct way. So let's look at an example here where we're multiplying a binomial, 3x plus 7, by a trinomial, x squared subtract 2x plus 9. So you're going to start off with the first polynomial, and that's what you're going to use to separate your brackets. You're going to start off with 3x, and that term is going to be multiplied by the trinomial x squared subtract 2x plus 9. Our next term in our binomial is positive 7, so we're going to go plus 7. And we're going to multiply that term 7 by the trinomial in the second bracket there, same thing we did in the first. So once we do that, we're going to use the distributive property. We're going to distribute the 3x into every term, and we're going to multiply by everything in that trinomial. So 3x times x squared is going to give us 3x to the exponent of 3, or 3x cubed. Keep it in mind about our laws of exponents. When we multiply, we have to add our exponents there. 3x times a negative 2x is going to give us negative 6x squared. 3x times 9 is going to give us a positive 27x. So there are 3 terms in the trinomial, therefore we must have 3 terms after we use the distributive property. Same process again now for the positive 7. 7 times x squared will give us 7x squared. 7 times a negative 2x is going to be a negative 14x, and 7 times 9 is positive 63. So once we do that, we're going to compare our like terms. Now you could group them from the highest degree, which is the x to the exponent of 3, to the constant term of 63. And when you do that, you have to compare and you have to add like terms. So there is no more term x cubed, so we're just going to leave it as 3x cubed. Next, if you notice, we have a negative 6x squared and a positive 7x squared. So we're going to combine those, and that's going to give us a positive 1x squared. Then we have 27x and a negative 14x. When we combine those, we get a positive 13x, and there's only one constant term of positive 63. So our solution for this multiplication is 3x cubed plus x squared plus 13x plus 63. So if you want to verify that now, you could choose a number for x, substitute it in for the binomial and then for the trinomial, and do the same thing for our answer and see if the left-hand side equals the right-hand side. Next we have two binomials being multiplied, and we're adding it to another two binomials that is being multiplied. So sometimes our question could be quite complex, but the process is the same as what we just did. So you're going to start off with dividing your first binomial into two terms, and you're going to multiply it by the second binomial. We're going to do the same thing for 2x subtract 1. 2x is going to be multiplied by that second binomial, and then negative 1 is going to be multiplied by that second binomial. Everything there in that second step is going to be distributed, so the 4x is going to be multiplied in, the 1, the 2x, and the negative 1. So once you do that and you work that all out, you're going to be left with 12x squared subtract 8x plus 3x subtract 2. That's going to be for our first bracket. And then we're going to have negative 6x squared plus 8x plus 3x subtract 4. And those four terms are going to be for our last two binomials. And then when we compare and add our like terms, we are left with 6x squared plus 6x subtract 6. So just because this one's a little more complex and there's a little more going on there, the process is the same as one we did previously. Just going to have to use the distributive property and add your like terms. So in summary, whether you multiply two binomials, a binomial and trinomial, or two trinomials, the process is the same. Distribute each term of the first polynomial by each term of the other polynomial. Once that is completed, you're going to combine your like terms and write the expression in terms of the highest degree. If you want to verify the solution and see if it is correct, you can substitute a number in for your variable, keeping it the same throughout, to see if the left-hand side equals the right-hand side. If this is true, then your solution is correct.